Okay, so here's part 2 of 8.4. We're going to talk about polyprotic acids. What are they? So they're basically an acid that possesses more than one ionizable hydrogen. So for example, H2SO4, sulfuric acid, it has 2 hydrogens. So it can be removed one at a time when the acid ionizes. So H2SO4 can first form HSO4 negative with 1 H plus, and then HSO4 negative can form SO4 negative 2. So the second ionization is very weak, however. Okay, so here's some common polyprotic acids. So they have 2 Kas, Ka1 and Ka2. And as you can see, Ka2 is really, really small usually compared to Ka1. Okay, so that's what it says here. Notice Ka1 is much larger than Ka2. Each subsequent acid gets weaker. So let's do an example together. So example, calculating the pH of a polyprotic acid. So here you have ascorbic acid, which is vitamin C, which is essential for our diet. Calculate the pH of a 0.1 molar solution of vitamin C, and the Ka values are given in table 4. Okay, so here's vitamin C, and we're going to do the first one where it loses 1 hydrogen. Okay, and we're going to do an ice chart for that. So it starts off at 0.1. Okay, and you just want to fill in using Ka1. So x times x is x squared divided by 0.1 minus x, and you can ignore that minus x because 0.1 divided by 7.9 times 10 to the negative 5 is way greater than 100. Okay, you square root it and you get 2.8 times 10 to the negative 3. Okay, so because we got 2.8 times 10 to the negative 3, you can find the pH from that. So you get negative log of that, so you get 2.55. Okay, so let's do reaction 2 when it loses its second hydrogen. So that will be Ka2. So here's the reaction here. Okay, and Ka2 is H plus times C6H6O6 negative 2 divided by the initial one. Okay, and they've asked us here to solve for, just let me look at the original question here. They've asked us to solve for, just the pH. So we're pretty much done at the end of this pH. This is just taking it one step further. And let's say they asked us to solve for the concentration of the last conjugate base here, right here. So this is just taking it one step further and showing you how to do that. So the conjugate base here, I'm isolating for it in this expression. So I take this and I multiply by Ka2 and I divide it by this, and you should get that. Okay, and then you just plug into your final concentrations what you have according to your ice charts. Okay, so the last assignment for that is page 525, number 1 to 9. Okay, take care guys, bye.